Factoring trinomials. This is a topic that many students struggle with, but it is a skill that you need to use again and again. In this video, I go over factoring by the cross method. I like this method best because it is the one that takes the least amount of time. Now, no matter what method you choose, you're going to have to spend time to practice to get good at it. In this video, I talk about factoring all different types of trinomials, so if you're only interested in a specific type, just click on the timestamps in the video. My name is Clara Tong. I tutor math online to students ages 11 and up. I used to be a classroom teacher, which is why I created this workbook to go along with the video so that you can have all my tips and tricks in front of you. In the workbook, I have 10 example questions, 90 practice questions, and the answer to every question. If you find this video helpful, please give it a like and subscribe to my channel for more content. When you multiply two binomials by double distribution, the result is a trinomial in the form x squared plus bx plus c. When you factor the expression, you're decomposing the trinomial back into the two original binomials. Factoring and double distribution are reverse processes of each other, so you can always check if your factored form is correct by FOILing the binomials back out. So I want to see if this trinomial is factored correctly. I'm going to FOIL x minus 5 and x plus 6 back out. You can see that my trinomial here does not match the trinomial that we started with, so that means that this is not done correctly. We can figure out the signs in the binomials pretty easily. We just have to look at our c value. So the last number in your trinomial, is it positive or negative? If it's positive, there are only two ways that the brackets can be arranged. That's because a positive number times a positive number is a positive, but also two negatives make a positive. Since the signs are the same in both brackets, we find b by addition. The only way to multiply to a negative c value is if one bracket is positive but the other one is negative. Since the signs in both binomials are opposite, it means that we're going to find b by subtraction. To summarize, whenever you factor a trinomial in the form x squared plus bx plus c, you're looking for two numbers that multiply to c and add to b. Here's our first example. We can see that c is positive, but so is b. The only way for this to work out is if both brackets are positive. So, what number multiplies to 10 and adds to 7? Our only choices are 5 and 2. To see if I factored correctly, I'm going to FOIL it back out. And yes, it is correct. You should always FOIL it back out to check your work, but I'm going to leave that as an exercise for the viewer in subsequent examples. In our second example, our c value is positive, but our b value is negative. In order to multiply to a positive number but add to a negative number, we need to have two brackets that are both negative. Negative 6 and negative 6 work. And since both our brackets are m minus 6, I'm going to combine that into m minus 6 all squared. Our third example doesn't have a b term at all, but you can think of it as if the b value is just equal to 0. In order to multiply to a negative c value, one bracket must be negative, one bracket must be positive, and when we add our two factors together, our result is 0. So here's our factored form. What if c has many factors? I've got a shortcut for you. If the factors of c add to a b that is too small, look for factors that are farther apart. If the factors of c add to a b that is too large, look for factors that are closer together. I've presented that as a rule, but now let me show you how it works. Let's consider this example here. We know that our two brackets are negative because c is positive and b is negative, but how do we know which combination should work? There are so many factors of 48. There's 1 in 48, 2 in 24, 3 in 16, 4 in 12, or 6 in 8. But let's take a look at what happens when we add our factors. You can see that if our factors are far apart, when we try to add them, we're going to get a bigger number. If our factors are close together, we're going to get a smaller b value. So this is how I would use this fact in practice. Let's say I was trying to do this example 4. I would just pick the first factors of c that come to mind. I see that my sum is too small, so I'm going to try factors that are farther apart. On my second try, my sum is too large. So that means that one of my factors is between 2 and 6. My other factor is between 8 and 24. In example number 5, I start the same way. Here we can see that our C value is negative, but so is our B value. That must mean that one bracket is negative and the other one is positive. Also, our B value is found through subtraction. 90 is also a number with a lot of factors. I just pick any two factors of 90 that I can think of. I can see that my difference is too large, so I'm going to find factors that are closer together. Now the difference is too small. So that means that one factor must be between 3 and 9. The other is between 30 and 10. Not all trinomials can be factored. Can you think of any two numbers that multiply to 4 and add to 6? I can't. If there is a greatest common factor present, you must factor it out. What can 2x squared, 18x, and 40 all be divided by? 2. But since the first term has a negative, we must factor out the negative 2 instead of just 2. After we factor out the GCF, we factor x squared minus 9x plus 20 as normal. The next example has a fraction in the GCF. I see a lot of my students get stumped by fractions, but you have to remember that the procedure is still the same every time. We're going to factor out half p because that's the GCF. Then our first question is, what does half p multiply by to get half p cubed? We need to multiply by p squared. The second question is, what does half p multiply by to get 4p squared? If you don't know this one off the top of your head, you can come up with the answer by using the fact that multiplication can be undone by division. The question now becomes, what is 4p squared divided by half p? Now that's 8p. Same with the third term. What is 6p divided by half p? That's 12. And we factor the remaining trinomial normally. What if the coefficient of the first term is not 1, but there's no GCF? We can use the cross method. The reason why the cross method works is because factoring undoes FOIL. So if we have a surefire systematic way to find out what the factors are, we can factor these trinomials quite easily. The way that you're probably used to seeing FOIL is when the two brackets are side by side and you draw these rainbows. Well, I'm going to rearrange these so that the two brackets are one on top of the other, so that the FOIL procedure becomes a little crisscross. Here are the step-by-step instructions. But let's do an example to put it into practice. There are only two possible factors of 2x squared. My C term is negative 12, but I'm not going to worry about the negative sign right now. All that means is that one bracket will be negative, the other positive. Factors of 12 could be 1 and 12, 2 and 6, or 3 and 4. I don't know which one it is, but I'm just going to pick one. I also don't know if 3 should be on top and 4 on the bottom, or 4 on top and 3 on the bottom. So I'm just going to pick one combination and see what happens. If I'm not correct on my first guess, it's okay. So now we see that the F part of FOIL is working out, and so is the L. So what about the O and I? If we multiply the O and I, can they add to negative 5x somehow? We're getting 6x and 4x. There's no way to get negative 5. So I'm going to switch the position of the 3 and the 4 and see if this helps. It does. 8 and 3 can definitely make 5 if the 8 is negative. Now I ask myself, where did the negative 8 come from? The 8 was made with the 2 and the 4, so the negative is going to go with the 4. Now that the combination of factors is correct, we can write the two binomials side by side. I know what you're all thinking. This is just some sort of fancy guess and check. What if both ax squared and c have a lot of factors? Won't guessing take forever? Not with these pro tips. Let's look at example 10 here. 6 has multiple factor pairs. 18 has multiple factor pairs. How do we get the right combination without trying them all? Let's break down the thought process. The first guess is always a random guess. We know the bracket sign situation. There's also this one odd pair bits. Remember, if the B term is odd, like 23, either O is odd or I is odd. If you multiply these two and they're both even or they're both odd, there's no way to add them together to get an odd number. So if I choose 6 and 3, the 6 must be placed opposite the 6x and the 3 opposite the x. I can't switch them around. Okay, so this didn't work out. Instead of x and 6x, why don't I try 3x and 2x? This doesn't work out either, but do you know what else I noticed? 12 and 9 are too close together on the number line. We need a larger difference of 23. So here's my third guess. It does work out. Since the 23x is positive, that means the 27x is positive and the 4x is negative. Of course, if you had started with a different random combination of factors, the path you take to the final answer will be different. However, the general game plan is still the same. Start with any random combination, and then use these pro tips to find out what the problem is. Did you miss accounting for whether b is odd or even? Do you need to increase the gap between O and I or decrease it? You will have some idea of how to fix it. Even if your second try is not correct, you're still getting closer. If you trust the process, follow the procedure, and do the practice questions, I have no doubt that you will be a master at factoring all types of trinomials. Once again, you can download the workbook in the link in the description below. Thank you for watching, and I will see you in the next video.